Hello, this is Mrs. Schuver, and welcome to our first lesson in Proportional Relationships Unit. Chances are some of the things we're going to talk about in this unit, particularly this first page, may be somewhat familiar because I believe you've talked about it in 6th grade, and chances are you've already talked about it in 7th grade. So the first thing I want to let you know is you're going to need a calculator for this unit. And at any time, if you'd like to pause this, you can, and stop and work out the calculations that you're asked to work out, and then start it up again. Also, I wanted to let you know this first lesson 1 might go a little bit long. I'm going to try to keep most lessons 15 minutes or less, but because this is 2 pages of introductory material, it might go a little bit longer than that. So let's start with our topic today. We're talking about ratios and rates. And so we're going to first fill in what we know or what we're supposed to know regarding ratios. As we read, it says a ratio is a blank of blank numbers. It can be written in blank different ways. So a ratio is a comparison of 2 numbers. And it can be written 3 different ways. An example of this could be if I use the days of the week, how many days of the week begin with S compared to all of the days. So I might say that there's 2 days, Saturday and Sunday, that begin with S compared to 7 days. So we can actually use the word 2. We could also write it this way using a colon. However, the preferred way to write it would be like a fraction because we can use it like it's a fraction. Next, the order in which we write the ratio is blank to the meaning. Ratios, like fractions, can be simplified. So the order in which you write the ratio is important. For instance, I mentioned the days of the week that begin with an S compared to the total days of the week, and so I started with what I said. There are 2 days of the week that begin with S compared to 7 days. Next, we're being asked to use the pictures below to practice writing ratios. So we're going to try to apply this. So I'm going to start with smiles to total. I'm going to look right here. And as I look at this, I see that this face has a smile and this face has a smile. And even though some of them have teeth, I suppose that one of them with teeth could be considered a smile, but those 2 are clearly smiles. So I'm going to write this as 2, and then it says to total. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total. And it mentioned above that we can simplify this. So if you recall how to simplify, you try to find the greatest common factor. And I can see that 2 will divide into 2. It's a factor of 2, and 2 is a factor of 12. So the best way to write this would be 1/6. Next, we're asked to find the smiles to tongue. So if I look at this, there's smiles. I notice again, we're going to go with these 2 smiles. And now I'm going to look at any picture that is showing a tongue. And right here, I see one picture that's showing a tongue. So I could write this as 2 smiles compared to 1. You may notice that we'd be able to simplify this to just 2. However, since they're asking us to write a ratio, in this case, when this happens, if you are left with a whole number, the assumption is that the 2 is talking about whatever was mentioned first. In this case, faces with smiles. And then since there's not a bottom number, again, it's assumed, if there's not a bottom number that's given, that this would be the number of faces that's showing a tongue. So please, at this moment, would you pause the video and would you try working on the first with teeth to teeth, and then the second, big eyes to teeth. And we're going to assume this little dude doesn't have big eyes because we can't see his eyes. So hopefully you counted 1, 2, 3, 4 pictures that had teeth compared to no teeth. 1, 2, 3, 4, 5, 6, 7, and 8. So 4 to 8. And because we prefer using ratios like fractions in reduced form, the greatest common factor that would go into both of these would be 4. So we'd prefer to use the comparison 1 to 2. Next, we're asked about big eyes. So I see 1, 2, 3, 4, 5, 6 figures that have big eyes compared to teeth. So I see 1, 2, 3, 4 faces that are showing teeth. So again, the greatest common factor for both of these would be 2. And so we'd prefer to write this as 3 over 2. So 3 faces compared with big eyes compared to 2 that have teeth would be the reduced form of this. All right, now let's go on to our next definition. So if we look at this next definition, it mentions rate. And a rate, it says, is a specific blank of 2 quantities with different units. And that's important. So what I'd like you to do is I'd like you to highlight different units, or you can circle that. It also mentions, now it wants us to give some examples. But before we do that, we have to know that a rate is a specific ratio. So it just compares 2 different types of quantities. Up above, we talked about different faces. So they're all faces. They just have different features. We talked about the days of the week. They're all days of the week. They just 2 of them began with an S. Some examples of rates might look like this. We might say that a car can travel 220 miles in 5 hours. Whoops. Okay. So the 2 different quantities are miles compared to hours. Or we might say that it costs $8.99 for 2 pounds of cheese. So again, now we're talking money is one of the quantities, and pounds is another quantity. So our next definition is a blank describes how many units of the first type of quantity corresponds to 1 unit of the second type of quantity. And this is known as a unit rate. So unit rate. And you're going to notice it has the word rate. So we know that it's going to be 2 different types of quantities, but what's important is the fact that we mentioned unit. So when you hear unit, it's talking about 1. So using our examples above, I might say that a car can travel 55 miles per hour, which means for 1 hour. And we like to abbreviate that as MPH. Or we might say, in this case, that it costs approximately $4.50 for per 1 pound per pound of cheese. So if we say per hour or per pound, the implication is that we're talking about one. You've also probably heard of miles per gallon. Cars like to tout how many miles per gallon their car gets on car commercials. For instance, 24 miles per gallon. That's an abbreviation. All of which are unit rates. So now let's investigate this. Let's try to build on this, and let's put this to play using an example. So what we're given is that Hunter jogs 4 miles in 30 minutes. Ryan jogs 7 miles in 45 minutes. And what they want us to answer is, what is each person's rate of speed? And who jogs the fastest? So right now we're given different amount of miles. Hunter travels 4 miles and Ryan travels 7 miles. And Hunter is jogging for 30 minutes and Ryan is jogging for 48 minutes. So the only way to compare this is to make sure we find the rate of speed per minute in this case. So one of the ways we can do this is we can set up a ratio. And we're going to talk about Hunter right now. So we're going to go with Hunter. Hunter's information that's given is 4 miles in 30 minutes. So I'm going to write that as 4, let's go back to the pen. 4 miles over 30, or compared to 30 minutes. So if we're going to try to find a unit rate, one of the most efficient ways to do that is to take the top number, whatever they give us, in this case it's 4 miles, and divide it by the bottom number. And we often use this, as you remember, not only a fraction bar, but to mean division. So would you take a moment, pause, and do that on your calculator, please? All right, after we divide 4 divided by 30, the answer is 0.13 repeating. And what that means is that Hunter his rate of speed is 0.13 repeating miles. Remember, that's what we started with on top, per minute. And that's known as a unit rate. So we know how fast he's traveled. So now we're going to go to Ryan's information. And what was given for Ryan is that he could travel 7 miles in 48 minutes. So once again, in order to find a unit rate, the most efficient way would be to take the top number, in this case it's 7 miles, divided by the bottom number. In this case it's 48 minutes. And when we do that, I'll let you pause to try that on your calculator. Hopefully you came up with 0.146. So we can now say that Ryan traveled 0.146, are pronounced as 0 and 146 thousandths miles per minute. And that's a little bit messy, if you don't mind me just scribbling that out for time's sake. The last question is who jogs the fastest? And if we compare the two, the person that jogged the fastest was Ryan. So Ryan jogs faster. And as I look at time, I think we will complete the rest of this lesson tomorrow. So what you'll look for is lesson 1, page 2.